session 9, we are going to see about relations. What do you mean by relation? Before looking into relations, let us see the recollection of cross product. What do you mean by cross product? As you know very well, if there are two sets, capital A and capital B, and let us consider the capital A set has the elements A, B, C. The same way, let us consider B elements are 1 and 2. You know very well what do you mean by cross product. Cross product is nothing but just linking each and every element of the first set, that is A set, to this B set. That is cross product. So this A will be linking to 1 as well as this A will be linking to 2. In the same way for B as well as for C. This we used to call by the name cross product. So A is linking with 1 and 2, and C is linking with 1 and 2, and B is linking with 1 and 2. So our cross product A cross B is nothing but A, 1, A, 2, B, 1, B, 2, C, 1, C, 2. This is the ordered pair of cross product. So this is what our cross product. Now let us jump into relation. What do you mean by relation? Now we have a ordered pair, that is all the possible ways of linking element of first set to the second set is here, but from here we are going to select some elements. Sometimes we may select all the elements, sometimes we may select some elements from this set using some rule. So by getting elements through a particular rule is called by the name relation. Now let us see what is relation. Let us again see the same set A and B with some different numbers. Let us consider A has 2, 3, 5, and in B let us consider we have 4, 6 and 10. So if we do the cross product, 2 will be linking to 4, 2 will be linking to 6, 2 will be linking to 10. The same way 3 to 4, 3 to 6 and 3 to 10. The same way 5 to 4, 5 to 6 and 5 to 10. So now it is our cross product. But now what we are going to do, we are going to define a rule to get relation. Now it is simply A cross B. If you want to find A cross B, it is very simple. 2, 4, 2, 6, like that it is going on. It is the ordered pair of A cross B. But now among this we are going to use some rule. So the elements which obeys to that rule are taken into account of relation. Now let us consider a rule. A divides B. That is, we are going to frame a relation set. There the condition says A must divide B. For example, now 2 divides 4. So we can select it. 3 will not divide 4. So we should not select this pair. So 2, 4 can be selected and 3, 4 cannot be selected. So in this cross product from this A cross B, we are using a particular rule, that is A divides B. Small a belongs to the set capital A and small b belongs to the set capital B, right? And we are going to select the elements which obeys to this rule. If you see, 2 divides 4 and 2 divides 6, moreover 2 divides 10. So we can use 2, 4, 2, 6 and 2, 10 for our relation. These 3 can be taken to our relation. Similarly, if we go for 3 won't divide 4 without remainder. So we cannot choose 3, 4. We cannot choose this pair. That is, we cannot choose this element. But 3 divides 6. So we can choose 3, 6. But 3 will not divide 10. So we cannot choose this element. So if we consider 3 divides simply 6 alone. And if you consider 5 in the same way, 5 divides 10. So according to the condition, we have these 3 items. So if we put it in a set, our relation will be 2, 4, 2, 6, 2, 10, 3, 6, and 5, 10. All these elements obeys the rule A divides B. So from this cross product, we have selected a subset which is obeying this condition, and that subset is our relation. So if we mark the relation, the A set is the same, 2, 3, 5, and our B set is 4, 6, 10. Now the linking elements are 2 with 4, 2 with 6, 2 with 10. Then 3 with 6, and 3 is not connecting with any other element. Then 5 with 10. So this is what relation. So relation is nothing but it is a subset of cross product which obeys some rule, right? Now there are if you consider a graph, see, this is our x-axis, this is our y-axis. Here we have infinite number of elements, here we have infinite number of elements. So if we find r cross r, that is, if you take all the elements of x-axis as set A and all the elements of y-axis as set B, and if we do cross product, we'll get the whole plane, because one will be linking with 1, one will be linking with 2, one will be linking with 3, and it will be going on. So all the elements in the plane will be in r cross r. So this plane is our r cross r. Now if you define a relation, that is y is equal to 2x. Y is equal to 2x means if x takes 1, then y will be 2 into 1, that is y is equal to 2. So if x takes 1, y will be taking 2. If x takes 2, y will be taking 2 into 2, 4, like that. So we are going to fix some elements from this r cross r, and if we draw, we'll get a line. So the whole plane represents our r cross r, and this line represents our relation. So even our graph represents a relation, right? So what do you mean by, now I hope so you know what is a relation. Now in this relation there are 3 basic properties. For example, let me show you this example. That is r 2, 4, 2, 6, 2, 10, 3, 6, 5, 10 is nothing but our relation, as we have fixed A divides B rule, right? From this, if you see, our domain is the elements which is in the front, that is 2, 3 and 5. So 2, 3, 5 is our domain, and if you want to find what is its range, the element, the numbers which come back, that is 4, 6, 10. So our range is 4, 6, 10. So from the relation, if you want to find what is domain, you have to select the elements in the first one places, and if you want to find the range, you have to select the elements from the second position. So we can define this. We are mapping. We have the diagram like this, and if we want to define it, if you want to define the domain of the relation, that is this. All the elements in the set A is considered as small a, and all the elements in the set capital B is considered as small b. So domain is nothing but small a element. So domain of this relation is A. This small a belongs to this set capital A, such that this small a must be related with B which belongs to this relation, and this B should be in the set capital B. So simply, if we want to think what is domain, this elements makes the domain, and these elements makes the range. So in the same way, range of the relation is nothing but elements from the capital B set, that is small b. So this small b belongs to capital B, but the condition is this B must be, that is the element A comma B must be in the relation, and this A must be in the set capital A. If it is so, we can say this is our range. So you know what is domain, what is range? Very simple. Domain is nothing but the element which belongs to the first category, and range is nothing but the element which comes under some rules which is in the second category. I hope so you would have understood what do you mean by domain and what do you mean by range in a relation. Very simple. Now we are going to see three basic relations which is defined on a set. The first relation is called by the name reflexive. What do you mean by reflexive? Yes, R is said to be reflexive if A is related to A. For example, in a relation, if we have a number 4, 4 should be related with 4. In a relation, if we have some other particular value 7 or 10, the 7 must be related to 7. And if it is so, we can say that R is reflexive. That is, it has the property of reflexive. At the same time, what do you mean by symmetric? Just consider a relation has a set, element A comma B. The meaning is A is related to B. If the element A comma B present in that relation R, then B comma A must be there. If it is so, we can say that relation is symmetric. Moreover, the final relation is transitive. What do you mean by transitive? For example, in that set R, that is in this relation R, if there exist two elements like this, A is related to B, that is A comma B, and B is related to C, that is B comma C. If two elements exist like this, that is ending with B and beginning with B, right? Don't worry about the A element as well as the C element, only the linking element. So if there are two elements like this, A is related to B and B is related to C, the ending element and the beginning element are same, then there must be a element A comma C in that same relation R. If you find like that an element, then we can say that R is transitive. So there are three basic relations we can define on a R. The first one is reflexive, the second one is symmetric, and the third one is transitive. In case if a set R has all these three basic relations, we can say that as equivalence relation.